Hello, hello, hello.
Hello. Hello, Zach.
How are you, Zach?
Doing good, doing good. How are you doing?
Nice. It's end of the week, and yeah, done with work. And I'm planning to go fishing later today. So, going out with a couple of my friends for do some fishing. So excited at night.
Nice,
Yeah,
nice.
cool.
It's Friday evening for
And
you, and
you know,
yes, it's Friday evening for you, and we have a guest who is yet to see a Friday.
yeah, yeah,
You're
yeah,
telling
and
so.
yes, I mean, I want to tell that our AWS virtual community, Oceania, hosting for the second time, and the CFP is going to close tomorrow, which is 31st of December. So, sorry, 31st of January, not December. I'm encouraging everyone to submit your talk, and it's going to be a good experience, and it's happening fully virtually. And doesn't matter if you're a first-time speaker or multiple time you have done. And if you need any help, if you want to prepare for your speak, John's, myself, other amazing community builders, heroes can help you. And feel free to reach out.
Awesome, awesome, awesome. Yeah, I've added the link as well in the chat. So if you're somebody who's keen on finding a stage to talk about some of your journeys with AWS, and community is one such place. So do sign up and submit your CFPs. That said, you want to talk about what we're talking today, Zach? And you're the business expert, so I'll let you speak.
Yeah, I think today the connection is not much good with John's. I think hopefully it will get better. Yes, so we have a amazing speaker today. I think you already know. You might see in the cover. We are going to talk about something really interesting, which is, I love Kubernetes, and John's also loves Kubernetes now. Yes, he loves serverless, obviously, but he loves Kubernetes too. And we are going to talk about something, not a bird, but an amazing tool. And I've been using this since day one, and we have done a session in one of our previous podcasts as well. So let's welcome Amin from AWS. Hello, hello, Amin. How are
Hey,
you?
folks. Good morning and good evening. I'm doing well. How about you?
Doing great, doing great. Yeah, it's a Friday already for us, so 5
Yeah,
p.m.
it's Thursday here.
Yeah, Saturday's here. Any plans for the weekend?
Nothing much. It's rainy days in Seattle, so yeah, excited for spring already.
Cool. I think John's dropped. I think some technical issues having today, but no worries. We can go ahead with this. Yeah, cool. So we are going to talk about some amazing tool today, and we have been talking this since it was launched, and I think you know already. I've been using this for a long time. So I think let's get started.
Today we're gonna talk about KRO. But before that, since we're all Kubernetes users, I wanted to talk a little bit about Kubernetes and why we love it and why we're all here today. And so Kubernetes is about deploying applications. I mean, at least it used to be. Maybe like now we're doing a lot of cool things with it. But the simplest use case of Kubernetes is deploying an application. And typically what you would do if you want to run an Nginx app, you would have like a manifest like this one called deployments. I think all of us have written deployment manifests. And yeah, it's a short manifest where you have to specify your image, the port you want to expose, and some label selectors and number of replicas. And typically, if you want to expose this application to the world, you would go ahead and write something like a service that will expose it inside the cluster and an ingress that will expose it outside the cluster.
Yeah.
And typically, all of us started by using kubectl,
Yeah.
wrangling with those manifests manually, and then we learned that actually this is not the right way to do it. We needed a way to package those manifests because they can easily like grow and become very hard to manage. And like a few years after Kubernetes launched, we had Helm, which is like a pretty cool package. YAML files package manager where you could basically package your service ingress and YAML as templates, and you would like use Go templates and syntax to replace values in the deployment, ingress, and service. And so typically, what you would do is that you would go and provide a values YAML file like this one. Um, and based on those values, you can like tweak what's inside your templates. For example, here I'm like, we're using the Nginx image that will go directly to the template. And I think, yeah, we have a values, that image in here. So if you want one day to be on a specific version, like latest, or if you wanted to have something like the Zach show image, I don't know if you have like an image in here, you can like have something like this, like a custom image. Anyways, that's very cool. Um, but it comes with challenges as well. Is that there is really no way to validate in advance whether your template is going to work or not. So if you have some mistakes in the template in here, or like your deployment or your service, let's say by mistake you make a typo in image and it's like double E's in here, there's really no way to know if this is wrong or right until you want to deploy the Helm chart. And this is why we created KRO, is a way to be able to validate your manifests beforehand and make sure that they are compiled, or like they have some sort of compile meaning. So the same way you would create a values.yaml, something more Kubernetes native would be to create like these in a spec field of a Kubernetes manifest. So imagine you had like, hey, I want to like create this the Kubernetes way. I want to do something like V1, but I want to have my custom application in here. Actually, let's even call it, let's call it my application, and I want to put it under Zax.show/V1. If you wanted to do something, let's do V1 alpha 1. If you wanted to do something like this, typically in Kubernetes, you would need a custom controller. So you would need to write the CRD. You would need to write the custom controller in Go, implement it, test it, deploy it, and then you should be able to create something like this behind the scenes. Or with KRO, actually, you would do something simpler. I mean, I have an example in here that's very, very similar. So imagine you wanted to deploy your application via CRD, and you wanted to basically just do an application Zax show v1 alpha 1. In KRO, all you have to do is to describe your manifest, or like how the view of the world would look like behind the scenes. So there's the concept of what we call an RGD, or a resource graph definition, basically, which is the graph of the resources that you want to deploy. And in this situation, it's a deployment, a service, and then an ingress. So how you would do that in KRO is by writing this manifest in here, and I'm going to hide a few things so that we can focus on the right sections. There is this API configuration layer called the resource graph definition, and behind the scenes, what we want to do is, let me open the instance to the side as well. So if you wanted to have your RGD or your resource graph definition manage some sort of application, Zax show v1 alpha 1 and application, you need to start by how the CRD looks like. And the way you start that is by very simply like defining what your API version and what your kind will look like. So you do a v1 alpha 1 in here. your kind is application, and your group is Shack Show. And our spec fields go to the spec in here. So Crow has this very simple syntax or schema that allows you to write what the CRD should look like. So in here, you'd be like, hey, I want to input a name called like of type string and an image of type string that has a default that is an Nginx, and my replicas. I want to default them to tree, and optionally, I want to enable an ingress. Without getting into the status, but let's see how this actually translates into deployment, service, and ingress. So basically, in Crow, you would have a list of resources. You say like, hey, here's my deployment, and I want to use some templates and syntax to point into the schema spec name, which will come from here, and the spec replica, which will come from this line, and so on. So below you will find the service template as well, and you'll find the ingress template. Anyways, to really understand how this works, I think there is nothing better than just doing a demo. So I have a cluster with RGDs in here. Let me actually clear up the RGDs. So let's start from scratch. I'm gonna go and deploy this this RGD in here, and I'm gonna call maybe like for the application, I'm gonna do, let's keep it application. So if I go and apply -f RGD.yaml, and I go and inspect it, we can see that Crow already just digested this file, and it's telling us that it's active, which means that it's serving those types in the cluster. And if you do this -oy, you could see something super interesting about Crow, is that it has a topological order.
Yeah.
Which means that behind the scenes, Crow actually infers that deployments need to be created before service, and service needs to be created before ingress. This means that even if you like swap the orders in your resources, Crow will still like figure out like what is the right order to do that. And if I go ahead and create this application instance in here, actually, let's see if I do already have one in here. Oh, I do. So let me delete the applications first. So if I do get applications, okay, there are no applications anymore. I can go ahead and just create this file. So if I go and do instance, which instance stands for like an instance of the RGD, which is just this manifesting here. If I look behind the scenes, I will see one deployment. And if I do get service, I should see one in here. And if I do get ingress, I should see one in here as well. So Crow behind the scenes go ahead and create those applications for you, or like those manifests behind the scenes for you. That's the whole idea of Crow. It's like, hey, I just want to template things in a graph and be able to express them in a very simple way. Now let's get into maybe some of the. So this was like the happy path of, hey, my RGD is perfect, it's correct. What if my RGD was not correct? What if like behind the scenes, let me delete the application first. What if behind the scenes, like I made a mistake and I try to create like an ingress ABC that does not exist in my cluster? Like this is something that it should not even deploy into my cluster. So if I apply this RGD in here and I do get RGDs, I will see that it's inactive, which basically telling me like, hey, ingress ABC is not really a thing. So if I do -o YAML YQ, and let's look at the status. Yeah, because it's a list. Let's just see it this way. It would tell you like, hey, you know what? The ingress ABC does not exist in your cluster. So I'm not even beforehand, I'm gonna like give you feedback on what other things that work or not. Similarly, let's say in the deployment, you make a mistake and replicas actually, you don't do the S at the end. So if you go ahead and try to apply this RGD, the same thing, you should see It's still inactive, but this time the error is different because we fixed the ingress, but we made a mistake now in the deployment. So if I do, so it says like, hey, not found for field replica. There's basically no field called replica in the deployment, so it's protecting you for making those mistakes. There are some other interesting things like, hey, what if you make a type mistake? What if actually in replicas it's correct, but in here you pass the image, and the image we declare that as a string, and you can see here that if you put like a string inside replicas, technically the Kubernetes API server would reject this. So if we go and apply this RGD in here, we should see even a different error. You can see here like, hey, type mismatch, got string, expected an integer. So KRO does a lot of type checking behind the scenes and make sure that your graph not only is correct, but it's also like from a syntax perspective, it's really gonna be deployed. There are some other cool things as well, is that you would see here that a service is actually referenced in a deployment. Like in the selector area, we are referencing the deployment, we're getting the match labels, and we're putting them inside the selection of the service. What if the deployment as well try to get something from the service? So if you do service.spec, or let's say that metadata.name, this as well, let's fix the image in here. Let's do, so replicas, the correct one. So if we go to the app in here, what we're doing technically is that we are creating a circular dependency. Now deployment depends on service, and service depends on deployment. And if you try to apply this RGD, you should see an error that's telling you like, hey, failed to build the dependency graph because service depends on deployment and deployment depends on service. So yeah, this is like in a nutshell what KRO can do. I think just one of the features that, or like one of the things KRO validates before you deploy your application. Now let's talk real quick about the status field. So if I deploy again the instance, and if I do get applications, it says it's ready. And if I do -o YAML, let's do a YQ. Let's get actually the real. So if I check the applications, let's inspect this guy in here. So applications -o YAML, and let's get the status fields. You would see that KRO not only give you some basic conditions, but it's also told you like how many available replicas out there. So you can see here we have 3 available replicas. And if you look at the deployment conditions, those are like the conditions of the deployment itself. And the way we've been able to publish those custom fields is by writing those available replicas and deployment conditions directly in here, saying like, hey, go and pick up the deployment status conditions and the deployment status available replicas directly from the resources. So yeah, this is like very quick tour of KRO. And if I do get instances, or like, do I have pods in here? Yeah, you can see like pods that have been running just like just like a few seconds ago. I look at the deployment, you can see the deployment as well. Now, the interesting part is, what if something gets automatic, like by mistake deleted? So if I look at ingress, and I go and delete this ingress in here, my app ingress. So delete ingress, my app ingress. What will happen is that KRO will see that change and deploy it back to you. So if I do get applications, I will see that it's still active. And if I go to get deploy service ingress, I should see like the ingress just came back 19 seconds ago. So yeah, this is like the goal of KRO, is that like you define your view of the world, and it's gonna be all the time fighting to bring back your resources when they're supposed to be deployed.
So even though
that means
we deployed, it will get back.
Yes.
Control it. Yeah, nice.
Yeah. So now what if we go and modify the replicas to 5? Like I can go here and do like, hey, I want my replicas to be 5. I can go ahead and apply my instance again. And I should see my deployment saying like, hey, 5 on 5 ready. So you can directly control your applications from the instance, the same way you would do that from a Helm values file. Let's me go back. So this was the original one. Yes. So it's very similar to how Helm works behind scenes, except that you get like some validations, and it's a controller. So there's like some drift detection in real time, and trying to keep the desired state in sync with the actual state in the cluster. So yeah, this is it in a nutshell. I still want to get into some very niche, or not niche, but very common use cases of KRO. One of them is when you try to deploy resources like real infrastructure. And in this situation, that could be AWS resources. To manage AWS resources, there's a bunch of controllers that you could use to deploy them. One of the most famous ones is ACK and Crossplane. So those two projects, they allow you to create things like some manifests like these. Basically, if you want to create a DynamoDB table, you can define it like a Kubernetes resource, and you would be able to select the table name, the attribute definitions, and the key schema. So technically, if you wanted to use Helm, you could definitely do like in your template near the deployment, you can say like, hey, you know what, not before the deployment, but I want with my deployment to have a DynamoDB table. And this is a completely valid way of having your manifests deployed. So this Helm chart here would create a DynamoDB table, and it will create a deployment on the side as well. Now, here is the challenging part. What if you wanted to pass the table on that will be exposed in the status? So when you deploy this manifest, you will have actually, like table status, but you will have also like an ACK metadata, and you will have an ARN in there, which is going to be like some sort of string in here. Like, what if you wanted to pass this ARN to the environment variables of your container? Currently, there is not really a good way to do it in Helm. There's no way to say like, hey, I want to like reference an output of this resource into this other resource, and I want to actually wait for that ARN to exist before I even deploy my deployment. So what I'm going to show right now is actually how the DynamoDB table resource works, and I'm going to get into how you can use that with KRO. So we have this example in here of a DynamoDB table. I'm just going to modify the name because probably I created this table just like a few minutes ago. If I go ahead and do an apply ACK DynamoDB table, you can use kubectl to view your table and how everything works. So behind the scenes, you can do get table. You can see that it's creating, and eventually it becomes active. And if you hear your YAML manifest, you would see that you have the status ACK resource metadata, and you have your ARN in here and account ID. So yeah, this is like ACK in a quick nutshell. We'll try to use it in KRO. We'll try to actually expand our graph to instruct KRO to wait for this table to be ready, so to be active before even creating the deployment. So yeah, in order to do that, let's quickly modify our RGD and try to add something new. So at the bottom, let's add this new resource called DynamoDB table. And in the template, looks like Copilot already knows what I want to do, but I still want to bring my own template in here. So let's put this this template in here and be like, hey, I want actually to use this schema that name that spec that name slash table, and I want to do the same thing in here. If I go and update this in KRO, so if I do -o apply RGD, let's actually make sure that we have no applications. Let's go ahead and apply this RGD in here. Let me try to see. Oh, okay. See, I already have some feedback. This is very cool. So I made a mistake. Something is wrong. What's going on in here? It says like, hey, the deployment. Oh, it still has like a spec image in the replica. So I need to modify that. So let's make here replicas. And if I apply again, okay, it says it's active, but I still didn't wire the deployment with the DynamoDB. So let's actually go to the deployment in here and go to the environment variables. So DynamoDB table arm. Typically what you would do here, you would use like the same syntax like a DynamoDB table, a table arm, except that it's not a table arm, it's a resource metadata.
So this is something you usually do with CloudFormation or Terraform and other IAC tools, right? We use the reference from another resource to another resource, right? Easily.
Correct. So yeah, typically you would do this with CloudFormation or CDK or Terraform. The only difference is that I think except for Terraform, in CloudFormation, you cannot really or CDK, you cannot link Kubernetes resources into with either. I think with CDK you can, with CDKs, but CDKs and Terraform allow you to do this kind of things, except that they are not really controllers. So you run them once and then they just go ahead and deploy. Before I go and apply this thing in here, I'm gonna go -o wide, and you can see that in our topological order, it still says like, hey, the DynamoDB table, it gets deployed at the end. However, with this new syntax, if I apply the RGD, the order will change. So if I do -o apply RGD and I do -o wide, you can see that DynamoDB table moved to the front, knowing that it will actually be created before the deployment. And say actually you wanna wait for the sorry, not here, for the deployment to be ready before you even deploy the deployment. So you would do something in KRO. We have the syntax called ready when, which is basically saying like, hey, I want to wait for the table status to be active.
Yeah.
And let's see if KRO actually likes this. Maybe it likes it, maybe it's not. Okay, it says like everything is good. This is cool. And let's just make sure that actually table status, do -o table. Yeah, we have a table status and it's active. So I want to make sure that this value here is correct. It's all uppercase. And yeah, like now if I do, hey, my app instance with DynamoDB, let's do DynamoDB in here. And replicas is 3. I go and deploy the instance. I should see if the deployment came. No, not yet. Okay, I can see that actually there is a new table. I do get tables. I can see like this new table got created 19 seconds ago, and KRO waited actually for it to be active before it created the deployment. So if I look at the deployment, it is in here. And if I look at the service and ingress, I can see them also created 20 seconds ago. Now, here is the interesting part. If I go and look at my pods and I get, for example, one of the pods in here, I do dash o YAML, and let's say I want to see the environment variables. I can see that the DynamoDB got injected into the pods
Nice.
directly. So yeah, in a nutshell, this is what KRO can do. It lets you glue resources together as a graph and make them wait for each other when you're deploying, and make sure that if you go ahead and, for example, if I go right now and delete the DynamoDB table, it's gonna like get into a new mode and recreate your DynamoDB table and like re-inject the new ARN into your pods and deployments.
Yeah. I really like the ReadyWhen feature because I came across the same kind of situation that deployments created earlier than my pod identity association. So I had to restart the pods to get the tokens, right? So
Yeah.
I used that same thing for pod identity associations. ReadyWhen is active, then it waited. After that, it went really well and smooth. And
Yeah, like
we have a question. We have John Ajera. He's asking, can you future schedule a deployment?
as in like only create the deployment after, I don't know, for example, only create it during deployment hours, which is 9 a.m. to 6 p.m. Currently, no, but it's a feature that is coming to KRO, actually, what we call propagation control. So you only want to roll out like resource creation or resource updates during specific hours of the day. So yeah, actually we don't have that, but it's something that we call propagate when. So only propagate changes after, like for example, during specific hours, and that will be only, for example, if time that now is in between, I don't know, the syntax is not correct, but it would be like, hey, before 6 p.m. and time that now is after 9 a.m. These things are coming to KRO very soon, so you would control actually not only the creation but also the updates. Like I don't want you to roll out any changes after these times. I only want you to correct the state and only like roll out changes between these things in here.
Oh, this is cool. Thank you for that. Hope John, answered your question.
With that said, I want to talk about a specific thing in KRO. So, most of the times, one resource per kind is quite nice. Like it's cool. But in reality, you want to create a lot of deployments or a lot of pods, a lot of config maps, and like if you want to follow this syntax in here to create multiple deployments. Or let's say you want to create multiple DynamoDB tables. I think this is maybe an example that makes much more sense. What you would do in KRO, before this week, is that you had to define your DynamoDB tables multiple times. So you would have like a DynamoDB table 1, 2, and a 3, and I think I have another one in here. So like those are like 4 DynamoDB tables. And each one of them will need like a different name, a different unique name, and yeah, we've been working on a feature that actually brings the concept of for loops. Like, hey, I want to loop over this number of items, and I want to like a lot of resources behind the scenes to replicate those resources actually. So I'm not gonna do a DynamoDB table example right now, but we can do it if we still have time at the end. I do have an example actually with pods. Is that like, hey, what if you wanted to create something similar to a deployment controller, and you wanted actually to only give a set of workers? So when I create basically a set of pods, and each pod has a worker name. So in this syntax, what you would do, let's actually try to build this. So this is a worker pool example of an RGD that takes a list of workers, an image, and produces a bunch of like workers behind the scenes. So this would actually be, instead of my application worker pool, and we can call it here my worker pool, and we don't have a name. We do have a workers, so worker 1, 2, and 3, and the image is, let's call it Nginx. So behind the scenes, this technically should create 3 worker pods for you, because even though like we only have one template defined. So let's actually, before we explain what's going on, let's try to deploy it. And FYI, like I haven't tested all this stuff before, so I'm gonna be learning with you as I'm working through these examples. So if I go and do -f rgd.yaml, I should see if the RGD is valid or not. Actually, it tells me that worker pool is active. And if I go ahead and deploy the, let's make this instance in here. So if I go and deploy the instance, oh, called it workers. So if I do dash create F, I should see 3 worker pods got deployed just like 5 seconds ago. And if I go ahead and add one more worker, so number 4, if I go ahead and apply it, I should see one more pod getting created right now. Now let's get into the syntax real quick. This, like typically, if you had to do this with KRO without the without collections, you would have to replicate this template multiple times. But this time we have like this for each operator, or like directive, like in Terraform, where you would say like, hey, I have this new variable called worker. I want you to loop over the list of workers, and for each worker, I need you to create this pod. And you can see here we're using the worker as a suffix for the metadata name. So yeah, actually we could even, let me actually do worker pools. Let me delete that. And you see that I don't have any more pods. Okay, cool. Let's delete also the applications. Okay, we do not have any more pods. One of the things you could do is like, instead of giving your workers manually, you can be like, hey, I want to have like replicas, which is 3. And if you wanted to work with this, you would be like, hey, my index, or like my want to loop over replicas. And instead of workers, we're going to do replicas in here. So replicas is an integer, and let's default it to 3. And inside in here, we're going to use a string of an index. And if I try to apply this RGD, it's not going to work, I believe. Yeah, of course it's not going to work. The reason is this, there is no way to really loop over an integer. You have to specifically say like, hey, I want to like range from 0 to my number of replicas. So we have a cell function that lets you basically loop from 0 to the number of replicas. And if I apply this, okay, so what did I do in here?
Let's troubleshoot on a live stream.
Yeah.
Love it.
Oh, it detected that I actually removed a field from the RGD. So if you remember before in here, we had workers. And workers was a field that we removed from the RGD. And KRO was like, hey, I'm not going to allow you to do that. It's a break-in change, which is technically a real break-in change in the RGD. So there are 2 ways of doing that. You could either keep the workers list of like keeping, if I do this one, I believe it should work. Okay, apply. Okay, now it's happy. However, it's not even like letting us do break-in changes to the CRD. You could actually put an annotation saying crow.run allow breaking changes true. And if I go and apply here, no
It's
detections.
unknown.
Yeah. So if I do get RGD, okay, now it's active, and now it's like with this annotation, we are acknowledging that actually we're making a breaking change to the RGD, so we know what we're doing. So if I go ahead and apply this instance with number of replicas, we should see a worker pool. It says it's active, and if I look at pods, I can see like I have pods 0, 1, and 2.
Yeah.
If I go ahead and delete one of my worker pods, so let's say worker pod number 2, and I do get pods again, I can see that the pod got recreated actually. So Crow fights back if someone goes by mistake deletes one of the pods, like the desired state is defined here. Now, one of the cool things you could do is like, hey, you could report an aggregated status of all your pods. So basically, you can be like, hey, workers all running, and I don't know the syntax actually in here. So if I do worker pods, I believe it's for each pod status phase running. I need to let's see what if Crow is gonna like it or not. So, or it says still active. If I look at the worker pools, you can see all workers running is true. So yeah, it's added the new status field and it started aggregating all the statuses into one for our schema. You could do some very cool things like, you know what, I want to have 2 set of workers. And so this is worker pods number 1 and this is number 2. And instead of iterating over the number of workers directly in the spec, you could iterate over another pool of workers. So here we could be like, hey, I want to iterate over, sorry, not this one. So worker pods 2, I want to actually iterate over worker pods 1. And let's name this one 1. And I believe the syntax in here would become, so this is going to be worker pod, and this should be worker metadata name. By the way, I'm trying this stuff for the first time, so everything could blow up, but in theory, it should work. So we can be like, hey, you know what, secondary. So let's call this actually worker pod secondary. Let's give it a shot. Oh, actually, this one is worker pod. Okay, cool. Let's see the feedback. Ours says inactive. Let's see why. Oh, because we renamed worker pods to worker pod 1. Actually, this one should be also like worker pod 1. And if I do apply again, okay, now I see that it's active and it has a topological order 2. And if I go and look at my pods, I should see like more secondary pods in here that were like looping over the first array and then bringing more pods to life. So yeah, I think this is a very pretty fresh feature in Crow, less than 48 hours basically. And yeah, it's like for loops for objects.
Yes, because Crow controller, correct me if I'm wrong, because you delete the pod because it's not come from the deployment, right? So Crow itself healed it and recreate the pod. I mean, in native Kubernetes, it doesn't happen, right? When you delete the pod, it will go away. Yeah.
Yes, unless if you're using deployments. But in this situation, we're not using deployments.
Exactly.
We're creating pods directly. So if I go, for example, and create this one, it should technically come back to life.
Yeah.
You can see here it got created again 3 seconds ago. So it's
3
like you're
seconds.
having your own concept of deployments, but it's not really a
Yes.
deployment.
Yeah. That's super cool. We have one more question. Thanks. Same from John as well again. What about another scenario? Like I will apply, but the actual deployment will happen at exactly on after 12 p.m. More of scheduled deployments. Um,
So scheduling is not a feature in KRO yet. We
yeah.
call it like propagation control. We
Yes.
will definitely have this. It's just like right now, if you want KRO to deploy things after a specific time, there is not really a way to do it. I mean, I believe you could. There's some syntax that will allow you to do it with KRO, but it's not really like natively supported nor something we have. I mean, I can talk about it real quick. We have this feature called include when. So basically, I don't know if you've seen this, but when we were creating the example with DynamoDB tables, we had this only create the ingress when it's enabled. In theory, you could also, when it's enabled and the time that now that Unix is at some specific time, or like some like let's do hours. Only it's after, let's say 12 or like 9 a.m. and before 18. I haven't tried this, but actually, like now thinking about it, yes, you could do this kind of things with KRO. I need to double check if we have the time library yet, but if we have the time library, it should be able to only include an ingress between those specific times.
Nice. Thanks. Cool. Jones is back. Hopefully his camera and everything's working now.
So
Nice. Cool. I mean, yeah, that's really nice because as I told you, like I was using this since it was launched in I think 2024, if I'm not wrong. Greenway.
Mm-hmm.
Yeah. Because capabilities came last year, reinvent, right? So we did a session about this, like deep dive, and we deployed a full stack application using the ingress, IAM policies, roles, DynamoDB table, like pod identity associations and everything. Like, and yeah, it was really nice. And I'm still learning. Today I learned a lot of new things from you. And hopefully you can talk about if someone wants to contribute to the project, right? Like I have seen in the Kubernetes Slack channel, and people can contribute to this, right?
Yeah, absolutely. KRO is an open source project. It's under the Kubernetes 6 org, so it's part of the Kubernetes umbrella. Of course, open source contributions is something we look forward to every single day. We have a lot of contributors, and we need more help in a lot of other areas. There's always something to do for sure.
Yeah.
So yeah, if anyone is interested into contributing, just like drop by. We have a Slack channel. We have a bi-weekly community meeting. Everyone is welcome, of course, and yeah, it's like any other Kubernetes 6 project. It's quite common to see how these things come along together. Collections is one of them. There was like so many people providing feedback and people requesting and requesting features or reviewing the design doc with us. It's definitely the product of a lot of people working and thinking together and contributing to the project in so many different ways.
Yeah, thanks. I mean, so because we are running in different time zones, most of the users are just gonna watch the on-demand video later. So I hope if they want to reach you out, like they can reach you out via LinkedIn or Kubernetes Slack. Hope you don't mind.
Yeah, absolutely. I can also like share a link for the projects in here. We can you can definitely like either go to the KRO project directly, open a GitHub issue, or start a discussion, or come to our Slack channel or DM me directly. I'm super happy to talk to the people. As like it's part of my job actually to um, to work with folks from all over the world with um, yeah with on open source things.
Nice. Thank you. John, you have any questions?
Definitely learned a lot while I'm still figuring out my camera issues. But yeah, very good, insightful session though. But I'm gonna watch it later on as well because my mind was a little off trying to figure my camera, but definitely insightful.
Cool.
Thank you so much for this for this. Like I've even personally have learned new things about KRO right now. You know, like I'm still discovering it, and I'm playing with. I haven't played with KRO like this in this depth, like in a live stream. So doing like everything from the beginning, deployment, service, ingress, DynamoDB table, and then playing with collections. I think it's the first time I do this. And I'm also like learning about how KRO behind the scenes work. I've been seeing some logs on the side, like while we were doing this, and I'm like, actually, that's something I need to look at later. Like, what's going on in here? So, so yeah, definitely like, yeah, useful session for the developers as well.
Yeah. Sweet. Thank you, Amin. I think it's a bit late for you as well. So thank you so much for joining with us. And it was a nice session. And this all started at reInvent. Me and Amin had a coffee chat for like a couple of minutes, and we decided, okay, let's do a podcast together. It was a nice chat. Yes.
Yeah,
Cool.
absolutely. Thank you for having me, folks. Really appreciate it. Had a lot of
Yes.
fun.
Yeah, we love it. Like we fun, we enjoy, and yeah, that's part of it. So yeah, thank you so much again, and hope to see you soon in another episode, maybe in the future. Like I
Yeah,
hopefully
absolutely.
Crow gonna release a lot of features, and we can talk about more about this, right, Jones?
Absolutely, and happy to have you again, Emmy, on the podcast. We could do more things around Crow or anything other Kubernetes or any other topic that you want to talk about. Because we are all in to learn about everything tech, right? Be it in terms of cloud, Kubernetes, serverless, AWS, all in. And I also see John as telling that he learned a lot of things about EKS and with the new capabilities. He's learning also from the other side. So.
Yeah, I started a series of EKS platform enablement. So because my day job is a EKS platform engineer and play around with and work with a lot of EKS stuff. So I'm gonna post more about like other capabilities like Argo CD in the future and multi-account, multi-region deployments, those things. Yep. Cool. That's it. Thank you again. And oh yes, if you want to check the blog, you can have a look. I think you already have checked this. Nice. And hope to see you soon. And have a good weekend and good evening, good night.
Thank you, folks. Thank you for having me. Appreciate it.
Thank you all. See you in the next episode.